Alrighty, this question is going to be from chapter 4, from the questions number 22. And it is a 5 kilogram block has an acceleration of 0.2 meters per second squared when a force is exerted on it. A second block has an acceleration of 0.1 meters per second squared when subject to the same force. What is the mass of the second block? So to visualize this, we can draw two blocks. This one is accelerating at 0.2, and it had a push. So let's say someone pushed it with a force that we don't know, and it weighs 5 kilograms squared. And then the second block, someone pushed with a force that we don't know. We don't know the mass, but we know that it's accelerating at 0.1 meters per second squared. So starting with block 1, we know that we have a mass of 5 kilograms, an acceleration of 0.2 meters per second squared. So from that we can use the equation force equals mass times acceleration, which would be force equals 5 kilograms times 0.2 meters per second squared. And that should give us 1 Newton. So we can fill that in here. Too much. And then it says in the equation when it's subject to the same force. So we know that this is also 1 Newton in our second box. So then what we know from the second box, we can write in, we don't know the mass, so the mass is what we're looking for. Write x kilograms. Acceleration is 0.1 meters per second squared. And the force is 1 Newton. So we can use that same equation, force equals mass times acceleration. We know the force is 1 Newton, mass is x, and acceleration is 0.1 meters per second squared. X, or the mass, will end up being 10 kilograms. And that's what we're trying to solve for. That's how I would solve that question. If you're given same force and you know the mass and acceleration of one and the acceleration of the other, you can just set them up and solve like that.